Welcome. This is the introduction video for SAP HANA BI and BO training course. First, we look at the overview and purpose of these components, HANA BI and BO, how it relates to each other, and also how it relates to the functional module SAP ECC system as well as non-SAP IT solutions. Later on, we will get into the details about the training course. Any IT application, either it creates data or it gathers data. It stores the data in the relational database. This data is called OLTP data, online transaction processing data. The underlying data model for OLTP data is the entity relationship model, where you have the parent-child kind of relationship. And this model is very suitable for transaction type of processing, where we need to query a certain set of data and present it back to the users. But when it comes to analysis of the data, this is not the best model. The best model as per the industry standard is the star schema or the dimensional model. We will get into it later as we discuss the star schema and extended star schema as it relates to SAP. But for now, let's focus on this OLTP entity relationship data model. We need to do analysis of the data in order to get better insight about the business process, so that we can do some changes for optimizations, improve the process, etc. Basically, we need to convert the data into some kind of information, and that information then translates into business knowledge for better insights and process changes. Here you can see the properties of OLTP data listed on the left hand side, as opposed to the properties required for the analytical data. So in short, there is a gap which exists between the OLTP data and also our overall goals for the business in terms of improving efficiency, etc. And this gap is called a business intelligence gap, which is exactly what the SAP products HANA BI and BO tries to address. Now let's get into the details about HANA BI and BO. The OLTP data is represented in the form of cylinders, whereas the data which are used for analytics is represented in the form of cubes. This process is basically a two-step process, where in the first step we convert the OLTP data into OLAP data using SAP BI or BW. Okay. So the whole purpose of BI, to put it in very simple terms, is to convert the data, OLTP data, and then convert it in the form of OLAP data, cubes and DSOs, dataset objects, so that we can do the analysis of the data more easily. Once the data is in OLAP format, then we make use of the BO, business objects reporting tools, to consume the data. So it's easier to consume and do the analysis and reporting if the data is in the OLAP format as opposed to the OLTP format. This is one representation of the process. Again, this explains the two-step process. The first step is we have multiple data source in different formats like SQL, Oracle, DB2, etc. These are different types of databases on which the OLTP data resides, and using the BI tool, or there are other comparable tools in the market also. So the first step is to convert the multiple data source in multiple formats into OLAP cubes or DSO objects. So this is done using BI tool, BI, or it can be done in HANA also. The next step is to consume the data, consume the overlap data, either for reporting or for a further analysis of it. This is another such architecture. Different companies follow different architecture. This is one such thing. So we have multiple data sources, and then all the data is moved into operational data store. The data in the operational data store is typically whatever data required for the analysis, and here we use a ETL tool to move the data from the source to the operational data source. SAP ETL tool is BODS, it's Business Object Data Services, and once the data is in the operational data store, it is moved to data warehousing. That's where the conversion happens from OLTP to OLAP, and if required we can split it into individual data mart. Later on the data is consumed using the reporting tool like dashboards, Webby, etc., or it can be used for further analysis and data mining. So what are the different types of end user reports which is part of BO? We'll look at it very quickly here, but I will go into the details of each of these different reporting formats later on when I discuss the BO course content. But for now, let's quickly go through that. If you require a highly formatted report, then there is a crystal report component. We can also go for web intelligence if it is a ad hoc reporting where the user can create their own reports, or if you want a highly visualized report, then we can go for Celsius or dashboards. Dashboards are typically dynamic, where we can change the input values using some graphical interface, and the report graphics change accordingly. These are some of the typical reports, end user reports, which are generated or created using the BI data or HANA data. And it's not only restricted to the system or paper, it can be used for mobility also. We can push those reports to mobile applications like iPad and Android, etc. So again, these are typical highly visualized reporting which we can generate from BO tools. Okay, this is a simple but highly important system landscape. We need to understand the end-to-end layout of different components, how it comes into picture. Of course, in each of the training course, we will be going into the details of either BI, HANA or BO, but either you work in BO or BI, HANA, it's very important that you know the end-to-end landscape in real world situation. We need to know where the data comes from, what is the input to the system which we are working on. For example, if you are working in BI, you need to know what is the input to it, what is the output, how the data is consumed. Likewise, if you are in BO, we need to know where the different source systems from where we can get the data from, and what are the outputs from the BO. So it's very important to know the end-to-end architecture or landscape of any BI solution. Typically, we have a source data which can be either SAP ECC systems like modules, PP, production planning, material management, sales and distribution, or it could be a non-SAP solution where the database can be DB2, Oracle, etc. And once the data is in the database, it is kind of replicated or transported to the BI solution, where it is converted into overlap cubes or DSO. If it is SAP BI, it's converted to extended star schema data model and converted into overlap cubes or DSO. DSO stands for data set objects. and once the data is ready in BI, it can be consumed by the business objects for reporting purpose. So this is one such path. The other possibility is business object reports can access the data directly from the source system, or it can consume the data through HANA. The data from the source system is dumped into HANA, which is in-memory database, and then it is used in the reporting layer, PO. I will come to the difference between SAP BI and HANA, the advantage of using HANA over SAP BI later on. But for now, these are all the possibilities. SAP BI and HANA can coexist. If a client already has the BI setup in place, they have two options. Either they can port or migrate the BI data into HANA, or they can have it as an individual system if they want to have it that way. So the end purpose, whether you have BI or HANA or the data source, is to generate some kind of reports using BO or for analytical purposes like data mining, etc., and then for the end user. Let's summarize. The ECC system is like different modules like PP, SD, MM. There are multiple modules, functional modules in SAP R3. So those things forms part of SAP ECC, and BI at a very high level we can say its purpose is to convert the OLTP data into OLAP data, which facilitates easy analysis and reporting. Later on, BO is the reporting layer, reporting tools. Again, we have multiple types of reporting like crystal reports, Webby, dashboards, etc. And depending on what the user wants, we can use that. BODS is the ETL tool. Basically, it moves the data from point A to point B. In this case, we can move it from ECC system to BI. Okay, let's move on to HANA. What is HANA? When you have the BI, why do we need HANA? HANA, the definition is high performance analytical appliance. Why do we need HANA? Whether the data is in OLTP system or OLAP system, the underlying storage device is a mechanical device. It's a disk. It's very input output intensive, which creates bottleneck. Actually, we need a lot of time to read the data, write the data, and also to seek the data in the disk, which is very input output intensive, and it consumes a lot of time. And the memory are very expensive, and as I said, OLTP data, it's all optimized for transactions, and BI data can mitigate the transaction time to some extent, but still that's not the best solution. That is why SAP has proposed HANA. HANA is a in-memory database system. These are all some of the drawbacks of the traditional BI system. For example, we need to do the aggregation before we store the data, so that it's easier for us to report the data during the reporting process. So what is HANA? HANA, as I said, is a in-memory database. It's not only the memory, huge memory, it's also the software. It's a combination of software and hardware, which forms or which enables the different features of SAP HANA. What are these software features? What are these hardware features? For example, the hardware feature, you can have RAM starting from 128 GB up to 8 terabyte of RAM, and you have multiple processors, multiple blades, and you can have CPU, multiple multi-cores, up to 16 cores per CPU. These are some of the hardware improvements which SAP has come up with. So the net result is it speeds up the process, and also it has come up with multiple software features. It uses different like a tricks for text search, and then we'll go into the multiple software features which are enabled in the SAP HANA. So the bottom line is on the it speeds up the system. On the software side, one main difference between the traditional database and this is here the column store and the object store is enabled. Typically in relational database only the row store is there. The column store enables high compression. We'll look at the reason how high compression is possible when it comes to column store, and also they use partitioning and things like that. One main feature of in-memory databases, aggregation tables are not required because the data is already available in the memory and it can very quickly do the aggregation. And also the loading time is greatly reduced because the data is directly dumped into the memory. We need to just do the inserts for the delta data. So in short, HANA speeds up the process. Not only that, the delta management becomes hassle free because the system takes care of it. And the third thing is that data modeling is not absolutely required. It is better if we can do some modeling in the HANA, but it's not really required. We can actually dump the entire OLTP data into this and do the reporting of it. So this is going to save a lot of time. So in one such POC where 460 billion records were analyzed, the typical BI ran for 77 minutes, whereas the HANA completed the same analysis in only 13 seconds. So in short, we can say HANA improves the processing time, and also it saves time on data modeling, and also it becomes becomes easy for us to do the delta management. These are the three main advantages of using SAP HANA over BI. Now we will go into the course details of each one of these, HANA, BI and BO. Now let's look at the training details for the BI. We will be concentrating on 5 major areas for BI. We will start with data modeling, and then we will move on to extraction, reporting, performance tuning and broadcasting. What is data modeling? Data modeling is a process of converting the OLTP transaction data into info cubes, DSOs or multi-providers. The underlying data model for info cube etc. or the star schema or the extended star schema. So we will be taking one use case where we will identify the set of transaction data which are required for analysis, and then we will bring it over to the BI, and then we will create a dimensional modeling where we will identify the facts and dimensions, and then we will create a basic star schema as shown here. So we have the facts table in the middle, which are basically numeric values surrounded by the dimension tables. This star schema has got major drawbacks. In order to handle or fix those drawbacks, SAP has implemented extended star schema where we have the master data concept, master data tables consisting of attributes, text and hierarchies, which are then connected through a SID table to the respective dimensions. So here we are separating the static data, relatively static data, from the transaction data, which are highly dynamic. All the dynamic data will be stored in the fact table and the dimension tables, whereas the relative static data will be stored on the respective master data table. We will be creating this extended star schema for the same use case. Initially we created the star schema Later on, we will identify the drawbacks of using the star schema. Then we will build a extended star schema for the same use case, so that we can clearly understand the advantage of extended star schema as well as the steps required to build the same. So this will be part of the modeling section. This is one of the major and very important subject or topic as far as BI is concerned, because a properly designed data model is kind of 50% work done. Okay, the rest of it is simply extraction and maintenance of delta and administrative work and reporting, etc. But the major focus should be on the data modeling, which we will be covering. So we will create InfoCube DSOs or dataset objects, which are required whenever we want to have a detail level reporting, and then multi providers, where we use multiple info providers to serve as a source for reporting. The second topic will be extraction. Extraction is just moving the data into BI. We can move the data from ECC system, where we use the data replication technique, and we will also be going into different types of extraction like generic data extraction using views, tables or queries or functions, and then we will also look at the LO extraction concepts and COPA extraction concepts. These are the very important and widely used extraction techniques as far as data replication is concerned. We will also be using flat file as the input to bring the data over into the BI. So that is the extraction part. And the third section is the reporting. BEX is the reporting platform within the BI. We can also use other reporting tools like BO, etc., but those are for advanced reporting purpose. The inbuilt reporting platform for BI is BEX. So we will be learning the BEX, analyzer, query designer, report designer, web application designer, etc. BEX analyzer is just like an Excel with add-on, where the data is presented in the Excel format for the end user to do the analysis and comparison. Query designer is more like the same results in the web. If the user prefers to see the results in the browser rather than in an Excel sheet, then we can use query designer. Report designer and WAD or for more advanced and formatting type of reports. For example, we can have a built-in drop down for selective reporting, or we can have a pie chart. There are a lot of reporting options available, and for that we will be using the report designer and WAD. We'll move on to the performance tuning, which involves aggregation, BWA compression. We will be dealing with multiple techniques as part of performance tuning. Then we will move on to the broadcasting, where it's where we decide when to send the reports, to whom to send it, and we'll also be dealing with the user authorization, things like that, as part of broadcasting. Broadcasting also involves the mode of sending the reports to the user. Like for example, we can actually host the report in the enterprise level portal, or we can send it via email. We can use the Word document, or we can create it as a PDF. So there are different options available, and there is a concept called report busting, where we can split the report and send only the relevant portion of the big report to individual end users. So these are the things which we will be seeing as part of broadcasting. So these are the 5 main areas which any BI consultants are required to know as part of their day-to-day job. As said, there are other areas, like minor areas like transportation and BI content, things like that. Those will also be covered as part of this course, but the main focus is going to be on this. We will be doing testing, test verification of the data once it is loaded into the InfoCube. Those things will also be covered. Just to get into a little bit more detail, we'll be covering the basic concepts of data warehousing, which is technology independent. There are multiple products available for data warehousing solution. We will be dealing end to end the basic concepts of why do we need a data warehousing and the data modeling for any data warehousing. Later on we will come specific to the SAP BI, where we will be creating the info cube, load the data into the info cube, check the data quality, and then we will create the queries and workbooks using the BIX tools, then manage the user authorization. So things like that. Then we will also get into the optimization techniques like aggregates and multi-cubes. We will be seeing about a dozen techniques, performance tuning techniques, which we can apply to the exercise which we would be doing as part of this. Later on we will also be doing the DSO, data set objects. As I said, this is for more detail level reporting as well as for delta handling. We'll look into the business content and also different types of R3 extraction, things like that. So this is a comprehensive course covering all the important topics of BI, as well as we will be dealing with end-to-end solution, starting with ECC solution. Then we'll talk about HANA, we'll talk about BO, we'll talk about the other reporting tools, how it can all come together as a ecosystem to form a enterprise level data warehousing solution. And then we'll focus on the core concepts of BI. I hope you enjoyed this presentation. If you are interested or if you require further information, please contact. Thank you.